Hello everyone, my name is Jonathan Ricco. I'm an associate professor in the Education Center for Humanities and Social Sciences at National Yangming University, where I teach English. I also have a joint appointment in the Institute of Philosophy of Mind and Cognition at National Yangming University, and I teach part-time at National Jiaotong University. So today I want to talk to you a little bit about my research, which is in the history and philosophy of science. And specifically, it concerns the scientific realism debate and late 18th and early 19th century chemistry. So what is the scientific realism debate about? Well, one way to put it is in terms of a question. Does science give us knowledge of unobservables, for example, atoms, electrons, and genes? These sorts of things are unobservable because they're too small to be seen. So on the one hand, our current best theories are very good at explaining and predicting observable phenomena. Some people ask, well, wouldn't the success of these theories be a miracle if unobservables like atoms, electrons, and genes didn't exist? On the other hand, when we look back at the history of science, we see a lot of unobservables that were eliminated from science. For example, the optical ether, phlogiston, and caloric. And so some people ask, well, how can we be sure that the atom, the electron, and the gene won't join these other entities in the graveyard of science? So I think these two thoughts are good for framing what the debate is about. I don't think that either of these thoughts is a good way to approach the debate. And I have another approach to the debate, which I prefer. So according to this approach, we shouldn't ask whether science gives us knowledge of unobservables in general. Instead, we should ask whether science gives us knowledge of particular kinds of unobservables, for example, electrons. Then what we can do is look at science in order to answer this question. So for example, your physics textbook might tell you that J.J. Thomson discovered the electron in 1897. Well, we can ask, did he? Was his measurement of the mass-to-charge ratio enough to conclude that electrons exist? We can go a little bit further and examine Robert Millikan's measurement of the charge of the electron in 1910. And we can ask, was that enough of a reason to conclude that electrons exist? So another area of research that I'm interested in is late 18th and early 19th century chemistry, which was an exciting time in the history of chemistry. One thing that shows up here is theory change. We get an example of theory change in the transition from the phlogiston theory to Antoine Lavoisier's oxygen theory. Another issue that shows up here is scientific discovery. Many elements are discovered around this time, including chlorine, potassium, sodium, and boron, just to name a few. Another interesting thing here concerns instrumentation and experimentation. And one of the things that I've looked at is the use of the voltaic pile to decompose chemical substances by means of electricity. So what I try to do is I try to use examples from this period in the history of chemistry in order to get clear on various issues in the philosophy of science. For example, the scientific realism debate, which I just talked about, the role of analogical reasoning in science, and the nature of scientific rationality. So that's a little bit about my research. Thanks for listening.